For Chapter 3, one of the main ideas was graphing linear equations, and linear equations make lines when they are graphed. And one of the forms that we spent a lot of time focusing on was y equals mx plus b, which is slope-intercept form. And in this form, y equals mx plus b, the m, or the coefficient of the x, is the slope, and the b is the constant, and that is the y-intercept, or where it crosses the y-axis. So when we have equations written in this way, y equals 3x minus 2, it's very easy to identify the slope, which is 3, again that coefficient of x, and the y-intercept where it crosses is negative 2. For y equals x plus 5, the coefficient is 1 for x, and then the y-intercept is 5. We also talked about another form of linear equations, which is in X and Y-intercept form. And to find where that line crosses the X and the Y-intercept, you plug in 0 for X, and then you plug in 0 for Y. And I'm writing them off to the side here for a second just so I can explain something in a little bit. So when I put x in for 0, or 0 in for x, that is, 2 times 0 is 0. So we're left with negative 7y equals 28. So y is equal to negative 4 because negative 4 times negative 7 is a positive 28. When we plug in 0 for y, we take care of 7y, which is 0, and we're left with 2x equals 28, so x is equal to 14. Now, 0, negative 4 is on the y-axis, so that is the y-intercept. And the x-intercept is 14, 0. And I wrote them off to the side because I think it might confuse you, or you might get confused that the 0, negative 4 would be the x-intercept because x is 0, but that's not actually the case. 0, negative 4 is on the y-axis, and 14, 0 is on the x-axis. So make sure you understand the difference there. So, again, on number 4, if we plug in 0 for x, that takes care of 4x, and we're left with negative 3y equals negative 12, so y is 4. And then when we plug in 0 for y, we get 4x equals negative 12, so negative 3 is the x value. So 0, 4 is on the y-axis, so that is our y-intercept. And then our x-intercept is at negative 3, 0. And then we looked at actually graphing. And a couple of different ways we talked about graphing. We can make a t-table and pick numbers for x and solve for y. Or we can use the slope-intercept form, which is a pretty handy method. Again, looking at y equals mx plus b, there's no b value, so that means that our y-intercept is going to be at 0, 0. And then our slope is that coefficient of x, which is 2/3. I'm going to pause the video and move everything up so that we can take a look at how that looks on the graph. So 0, 0 is the origin, that's where you start, and the 2/3 you go up 2 over 3. And you put a dot. You could also go down 2 to the left 3. This is a positive slope, so it's going to be going in this direction through the first and third quadrant. And again, you would get that same exact graph if you pick some points. For example, if I picked 0 for x, 2/3 times 0 is 0. So there's that 0, 0 point. You could also pick the number 3. 2/3 of 3 is 2. And there's that point right there on the graph. I could also pick a negative 3. 2/3 times negative 3 is a negative 2, which is this point right here. So whether you choose to use slope-intercept or make a t-table, you should get the same line. For number 6, I'm going to start by graphing that y-intercept at 6. So I'm going to come up here and put a dot right there at 0, 6. and the slope is -3/4. So I can either go down 3, 1, 2, 3, and to the right 4, or I can go up 3 and to the left 4. This is a negative slope, so it should be going in this general direction. And remember to always put those arrows at the end of the line. Linear equations have an infinite number of solutions, so we want to make sure and indicate that by putting the arrows at the end. For numbers 7 and 8, you're also finding the x and y-intercepts. That's because the x and the y are on the same side of the equal sign, it just lends itself to plugging in the 0 for the x and 0 for the y. And so, as I mentioned on the previous slide, the x-intercept is not when the x is 0, but when the y is 0, and the y-intercept is when the x is 0. So just remembering that, when we plug in 0 for y here, we get 3x equals -15, so x is equal to -5. And when the x is 0, we get 5y equals -15, which y would be -3. So the way this would be graphed is -5, 0, which is right here, that's the x-intercept, and then 0, -3, which is right here. It's a negative slope going in this direction. For number 8, it's pretty easy here. Our x and our y-intercept, again, when you plug in 0 for x and 0 for y, you get 7 in both cases. So over 7 up 0 and over 0 up 7 gives you these 2 points. It's going to be a negative slope looking like this. Alright, so we have just one more problem here for chapter 3, and that is taking a triangle ABC and plotting the points. So we have -6, 2, which is right here. We have -4, 0, which is right here. And we have -1, 5, which is right here. So we're going to just take a line and connect those. And that's the original triangle, letter A. B says reflected over the x-axis, so here is the y-axis, and I just noticed something that on the review sheet, PDF, I reflected over the y-axis and not the x-axis, so here's the x-axis. So what we're going to do is we're going to go 2 places in the opposite direction, so here's a point right here. And then 1, 2, 3, 4, 5 places in this direction. So it should look something like this. So our new points, we reflected over the x-axis, should be A, which I should have labeled these when I graphed them. There's A, there's B, and there's C. So our B prime is the same exact point, which is -4, 0. Our A prime is -6, -2. And our A value, our C value, C prime, is -1, -5. So if you notice, when we reflected over the x-axis, all of the y values became negative except for the b prime. And I think on the PDF that I posted of the answers to this, I reflected over the y-axis on mistake. So we'll see how many of you actually catch that. So that's chapter 3 in a nutshell. Hope that helps you with your final review.